Okay, now let's talk about the DICOM protocol data units, or PDUs. Protocol data units, or PDUs, are simply the different types of DICOM messages involved in DICOM associations and data transfer. Are you ready to meet them? Ta-da! Here they are. Meet the PDUs. A associate RQ is a request, which requests DICOM association. A associate AC accepts DICOM association. A associate RJ rejects DICOM association. P data TF transfers a block of DICOM data. A release RQ requests association termination. A release RP responds to association termination, and A-Abort aborts an invalid association. So first up, we have A associate RQ, or the request message. This is a request for DICOM association. It details the user information and presentation context. Those contain the function requested, the abstract syntax, and the supported formats, the transfer syntax. When you look at an association request message in a log file, it's easy to identify in several ways. The responding application name field will be blank because it's a request for association, so there is no responding application yet. The context ID will say proposed because it's proposing an association, and it will list several proposed transfer syntaxes. So let's take a look at one. Right, so you can tell that this is an A associate request because, right, the context ID says proposed. That's a very easy and obvious way, right? So we have the abstract syntax. It says this is the verification SOP class. You have the proposed and accepted roles, which are default, and you have the proposed transfer syntaxes here. So it's proposing little endian implicit, little endian explicit, big endian explicit, JPEG lossless, and all these other ones that we won't bother going into. But this is what an association message would look like. Right? And up here you can see that the responding application field is blank because nothing has responded yet. It's just a request for an association. A associate AC, an accept message. This is an accept of a request for DICOM association. It details the user information and presentation context, which contains the function, the abstract syntax, and the supporting formats of transfer syntax. When you look at an association accept message in a log file, it's easy to identify in several ways. One, the responding application name will be filled in because now you know who proposed and who responded. The context ID will say accepted, and it will say what the accepted transfer syntax is. So let's take a look at one. Okay, so now when you look up here, you see that the responding application name is filled in. You have the calling application, which is this AE title, which is actually my PC name, and you have the responding application, which is our AGFA system. You can see that this is an accept message because it says accepted right there in the context ID, and you'll see that the accepted transfer syntax here is little endian implicit. So you can tell that this has been accepted, and this is the agreed to transfer syntax between my PC and the AGFA system by looking at those messages. A associate RJ, or rejection. This is a rejection of a request for DICOM association, and there are two types of rejections. They are permanent and transient. A transient rejection means there is a problem with the association right now, but it might work later. This is often caused by network congestion or a device being at its max number of connections. Most vendors limit the number of concurrent DICOM connections a device can make. So let's say your device can have 5 DICOM connections. So a tech finishes a study, and this happens on modalities that have big studies like CTs and MR, and they start sending the first study. Well, just because the machine is sending a study to the PACS doesn't mean that it can't be used for other things. That happens in the background. So they bring the next patient in, they scan the next patient. CTs happen really fast. They're just a few minutes on the table. So if they have several big studies and maybe they have a slow network or there's some network congestion, they might have the last 5 patients being in some form of transfer. And so when you get to send the 6th study, it's going to say, nope, we can't associate and make this 6th connection because I can only have 5 active connections going at one time. Or maybe it's sending some to be archived and it's sending others, to be to other different pack systems or backup packs, or maybe it's pulling studies back from the archive. It doesn't have to all be sending in one direction. These could be all happening in different directions. You can't have more than a certain number of concurrent DICOM connections. So that would be a transient rejection where, hey, when we get below 5, then you can try to send this again. A permanent rejection means the association parameters are not compatible between the two devices. These two devices just do not get along. They don't speak the same language. They don't perform the functions that the other side of the equation needs. They're never going to connect. So the rejection messages contain 3 elements with numerical codes. The result element can be 1, rejected permanent, or 2, rejected transient. And the source can be 1, 2, or 3, with the most common being 3, service provider rejection, which means, hey, you asked if I do this service, right? The MR asked the archive, can you store images? The archive says, no, I don't store images. I mean, the archive would never say that because that's its whole purpose, to store images, but whatever service has been requested, the provider doesn't provide it. That will be a number 3 in the source. And reason uses codes 1 through 8, with the most common being 1, no reason given. And you'll get used to figuring out why the message was rejected without using these less than helpful reason codes. A-Abort. This is an abort connection message. It has the same structure and fields as the reject message, with the exception that the source and reason will always say no reason given. When an application entity receives an abort message, it will terminate the association as soon as possible. Okay, let's read this last line again. When an application entity receives an abort message, it will terminate the association as soon as possible. It's not an instant disconnect. When it says, hey, abort, if we're in the middle of transferring images, then it will finish whatever images it's in the middle of transferring. It may not finish all the images in the study, but, if you think of, a chest x-ray, if it's completed the data packets that compose the right lung, it's going to finish the left lung and then terminate that association. And abort is not an instant disconnect. It's a disconnect as soon as we're done transferring the image we're working on. PDataTF. This is the command object responsible for actually transmitting the data. PDataTF sends DICOM objects cut into chunks of data known as protocol data value items. More commonly, these are simply called data packets. So think of a chest x-ray. Now imagine taking some scissors and cutting that chest x-ray into 9 separate squares. Okay, so the whole image doesn't get transferred at once. The left upper corner gets transferred. Then the left upper center, then the right upper corner gets transferred. So these data packets contain the values that make up a piece of the image, like a jigsaw puzzle. And that's going back to A-Abort. It's not going to abort in the middle of sending parts of the jigsaw puzzle for the chest x-ray. It will send all of those packets before it shuts down the connection. A release RQ and a release RP, that's a request and a response to release the association, and this is the polite way for associations to end. One AE requests the association be terminated, and the other responds in agreement. When everything goes smoothly, this is how associations end. Here is a log file entry showing a successful DICOM ping followed by a release association. Okay, so if you just look here, they have requested an association. The association was accepted. Then they completed the service, which was a ping. The status was successful. And then it said, okay, let's release the association. That is a nice, polite way for two DICOM devices to get together, do what they need to do, and then separate on good terms. How associations end. There are 3 ways DICOM associations can end. They are by protocol. This is done by a release request and a release response message, usually after a successful transaction. By an abort message. This is done when something goes wrong in the transaction process or when the 2 devices are not compatible. And 3, by timeout. If there is no communication by one device for a certain amount of time, the other device will terminate the association. This usually happens when there's a sudden network or power outage, and the timeout setting is configurable on the modality. So again, let's go back to our CT scanner example. Let's say it has a 30-second timeout. If it has a connection to your PAX system and the PAX doesn't respond after 30 seconds, not hearing anything from PAX, boom, it will just close the association at that point. And again, that's configurable. You can set it for 30 seconds, you can set it for 90 seconds, whatever it is. You know, whatever works for your network. If you have a really slow network that takes a long time to respond, you're going to want to have a longer timeout setting. If you have a really fast network, you might want to have a lower timeout setting so that you don't build up a whole bunch of stagnant connections just sitting there waiting to time out, because remember, there's a limit to the number of concurrent DICOM connections you can have. So here you have the whole process in picture form. Here we have what looks like an ultrasound cart, and here we have some kind of a workstation. So you have the A-Associate request message. Then it either gets rejected, and that's the end of that, or it gets an accept message. And so assuming it gets an accept message, now they have a connection, and so the cart is going to transfer data, some type of image, right, in data packets or chunks. If something goes wrong, you'll get an abort from this workstation to the ultrasound cart. Assuming there's no reds in this transaction, it all stays green. Then once it's done sending, because only the cart knows how many data packets for an image it has to send, right? This side can't do a release because it never knows when this side will be done. Once it knows it's done sending, it will send a release, it will send a release response, and the connection is terminated. Voila. That's how it goes.